Problem 1123, you are given a binary tree. Find the lowest common ancestor of all leaves that sit at maximum depth. If every deepest leaf lies under the same fork, that fork is the answer. Here the deepest leaves are 7 and 4, both 3 edges below the root. Their lowest common ancestor is 2, the shallowest node whose subtree still contains both branches. Picture the deepest leaves as anchors at the bottom. Bottom up, each node asks its children, how far down can your side still reach? Those answers are just numbers. Deepest leaves light up first, then height tags appear in post-order, so every parent learns the tallest stack of edges hiding inside its own subtree. When both children return the same height, this parent is the fork for everything below them, not necessarily the whole tree, but for that pocket of leaves. Here each side reports one edge to a deepest leaf, so node 2 is the lowest place where those two anchors meet. If one child brings back a bigger height, the lowest common ancestor of the deepest leaves cannot be this high, it must lie entirely under that taller subtree. At node 5 the right branch reaches further down than leaf 6 on the left, so we ride that edge toward 2, where the tree finally balances again. Bottom-up post-order. Each line is height h to a deepest leaf in that subtree, plus the LCA candidate there. Leaf 6, h is 1, LCA candidate is 6. Leaf 7, h1, candidate 7. Leaf 4, h1, candidate 4. Node 2, both children return the same h, that means the fork where deepest leaves 7 and 4 split. This node is their lowest common ancestor, the candidate becomes 2. Node 5, the right child reports a larger h, relay LCA candidate 2. At the root the left report is deeper, we relay that pair. Candidate stays 2, return 2. The problem asks for the LCA of all deepest leaves, here, 7 and 4. When both children return the same height, that node is the fork and becomes the LCA candidate, that is node 2. When heights differ, we relay only the deeper sides pair, at the root the left subtree is deeper, so the final candidate stays 2. Let n be the number of nodes. Time is linear in n, one depth-first search visits each node once, and each visit does only constant time work before returning. Space comes from the recursion stack, its depth is the height of the tree along the path being explored, so it is order h, and on a skewed chain that height can be order n. Lowest common ancestor of deepest leaves, outer function starts the recursion from the root. Inner DFS returns a pair, height to a deepest leaf in this subtree, and the current LCA candidate there. Null node, height 0, no candidate. Post order, recurse left, unpack height and candidate from the left subtree. Recurse right the same way. If the left subtree is strictly taller, bubble up its height plus 1 and its candidate. If the right subtree is strictly taller, take that side instead. If both heights match, the fork is here, new height is 1 plus that shared depth, and the candidate is this node. After DFS finishes at the root, we have the overall height and the final LCA candidate. Return that candidate as the answer.